All right, so for these, I want you to have a graph so you can see it, because I'm going to want you to have this comparison idea down solid by the end of the page, I hope. Okay, so let's just draw a graph that I know where the area under the curve of f of x is equal to 5. All right, so that means if I have 0, let me just draw like an f of x. If I'm going out to infinity, right? So this I'll call f of x. If I know it adds up to 5, right? It's got to be a horizontal asymptote. So this area here is equal to 5, right? All of this shaded area is all equal to 5. Okay, so then let's say I know that this function f of x is bigger than my g of x. So let me try to get a different color going here. So here's my g. My g of x is smaller than my f of x, right? So I'm going to have g of x come in like this. It's got to be smaller than. Okay, so what do I know about the area of g of x from 0 to infinity? Do you think it's going to be smaller or bigger than 5? It's going to be smaller than 5, right? Because all of the black area is going to be 5, so the red area is going to be smaller than 5. Okay, so what if, just going to draw the picture again, I know that the area under f of x, here's f of x, this area here is 5, right? The black area is 5, and now I've got g of x is larger than f of x. G of x is larger, so here is g of x up here, right? And it stays up here. So what do you know about the area under g of x? The area under g of x from 0 to infinity, it's going to be greater than 5, right? Because there's more area that I'll be adding on. Okay, so hopefully this is feeling very comfortable. So this time I'm going back to negative infinity. It doesn't matter. So if I'm going 0 to negative infinity, and here is my f of x. So this area is equal to 3. And then now what am I saying? Now I've got this g of x that's bigger than f of x. So g of x is bigger than f of x. It's up here. And what do I know about the area under the curve between negative infinity and 0 under g of x if it's bigger here? Won't I know that this will be greater than 3? Yes. All right, so now same deal. I've got this f of x, negative infinity to 0. There's my f of x. So this area here adds to 3. Now I've got this g of x function that is smaller than f. So g is down here. So g is here, smaller. So now what do I know about the area under the curve between negative infinity and 0? It's going to be smaller than 3, right? Okay, so just I'm wanting you to compare. Well, if that's that and this is smaller, I want you to start getting that logic in your head. Okay, so here we go. So what do I know about 0 to infinity? It is going to change. It's not going to be the same thing over again, I promise. So 0 to infinity, that's adding this up. Oh, this adds up to infinity this time. Oh, so this cannot be added up. All right, now I have g of x is smaller than f of x. So the black is f of x, so g of x is smaller, so g is under here. Do I know that g of x adds up to infinity as well? No, I don't know anything. This 0 to infinity of g of x, this could equal a number and converge. So you don't know if I have something smaller, if it's going to be infinity or not. Curious, all right. So let's do this again. 0 to infinity. Now I know this f of x adds up to infinity, right? This one adds up to infinity. This time my g of x is bigger than f of x. So g of x is up here, comes down like this. So what do I know about the area under g of x? If I have f of x equaling infinity, Don't I know that g of x will be more than infinity? So do I know it will add up to infinity as well? Yes, I do know. Okay, so those are the ideas behind what we're going to be using for the comparison theorem.